Hello and welcome to Technical Utkranti. And today we are going to see the last section under greedy algorithm section. And here we'll be going to see some important concepts. So this video is about finding maximum number of activities that a person can do, given that you are having start and end time of all the activities. So before we delve into discussing this question, let's have a look on the thought of the day. These are the questions that we have done under greedy algorithm section, and let's look at the question. So you are given the start and end time of activities, and you need to find the maximum number of activities that a single person can do. So till now we understand that when the question has start and end times, and we have to optimize it in a certain way, the first thing we do is sorting. All right. So we have done two kinds of questions. One question is the current type, where number of activities are given and you need to find how many activities a single person can do. This is one kind of question. The second kind of question is that you are given start and end times of the activities, and you need to find how many people are required, or how many uh, objects are required to fulfill all these tasks. All right, you understand the difference between the two questions. So in both these type of questions, the approach is slightly different. So when you need to find the minimum number of persons to take up all the tasks, we begin with sorting both start and end times. We sort both start and end times. So this type of question is taken up in DSA 3.2, where we discuss how to find minimum number of platforms for given arrival and departure times. We need to take care of all the arrival and departure times, and we need to find minimum number of platforms. But if the question was different than this, slightly different, listen to me carefully. So if we say that we have only one platform, how many arrival and departures can we take care of? This is another kind of question. So this second paragraph illustrates how you take up this second type of question. So when you need to find the number of activities a single person, or number of arrival departure by a single platform that can be performed, it is easier to determine that if the database is sorted with just respect to the end time, or with just respect to the start time. So the beginning of the solution is different for the two questions. In one case, we sort both start and end time, and in another case, we sort the database with respect to just end time, or with respect to just start time. So we'll understand the difference in the two approaches shortly. So we have this start and end time of four activities with us. All right. Now, let's suppose that we want to find minimum number of persons to take care of all these activities. So this is not the current question of the uh, of the video that we are looking into, but just to understand the concept, I am illustrating to find minimum number of persons to take care of all these activities. So what we'll do is we'll sort both the start time and the end time. All right. Now see, this is the person one beginning with the first task. Now, let's suppose we are given that the start and end time of the activities can coincide. So the same person can finish this task and start this task, right? Then there can be person two that can start this task, because this is the shortest time that has to be taken care of now, right? Think about it. Now we have this. this end which needs to be taken care of. So P1 can finish with this, and then this is the shortest next smallest time that needs to be taken care of. So P1 can take care of this, right? And then the next smallest time is this. So P2 can end with this, and then P1 can end with this. So here we get to see that two people can finish this entire task. But so you understand, right? Here I had to calculate the minimum number of persons to finish the task, and this way I can calculate. The algorithm of it is explained in DSA 3.2. Go and have a look at it to understand the algorithm. All right. But here, if we want to see how many tasks P1 has performed, P1 has performed. It has performed 3, but count the number of tasks P1 has performed can be a little clumsy, because this these timings are not with respect to tasks. So for example, 1 2 is the start and end time of one task, 2 5 is start and end time of another task, but 4 7 is not the start and end time of the same task. These are the different tasks, as you can see. But this arrangement is done in order to calculate the minimum number of persons. All right. So in this setup, it is little difficult to find out how many tasks P1 has performed. For this kind of question, so how many tasks P1 has performed, what we'll do is we'll sort the database with respect to, let's say, n time. So we have 2, 5, 7, 8, and 1, 5 is 2, 7 is 6, and then 4. So we have sorted the database with respect to the end time. And now what we can say is P1 starts with 1 and P1 finishes 2, and by that time this task is also there. So P1 can take up this and get finished with this. And then there's this third task which starts after the second task. So P1 can take this up and finish this. And after this, this particular task is re- starting earlier than the end of this task. So now P1 can't perform more than these tasks. So as you can see, that it is very easy to count that P1 can perform 3 tasks in such a setup. So I hope you understood this algorithm, this approach, and the two type of questions that come up, and what are the approach towards both these type of questions. So now let's have a look at the code. So I have created this, I had start time and finish time. I have created one common database of both start time and finish time. And then I've sorted the database with respect to the finish time. So this is the important command in Python, by which if you have a matrix, you can sort that matrix with respect to a particular column. All right. So now we can start counting the number of tasks performed by P1. So when for the first task, anyways, uh, P1 will start off. All right. So here we'll note down the end time of the task. All right. Then from the second task onward, we'll see that if the start time of the second task is greater than the end time of the previous task, then increase the count and update the last end time. So this is done for the entire database, and the number of tasks that P1 can perform is determined. So let's see if this is acceptable. Yes. So I hope you liked the problem, the approach to solving the problem. You understood the two types of questions and the approach to solving both type of questions. And if you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.